All right, so we are live now. We get to go round two.
Oh, nice, nice. So we get to continue where we picked up, right? From
So
last time.
yeah, I went on a little vacation to Tennessee, so I'm trying to remember where we left off. I know we went through the DeepStream API a little bit and talked a little bit about that, the configuration formats, and talked a bit about syncs and things. And then I think we ended up where we got a demo running. And I'm trying to remember what demo that was. I think it was just multiple video feeds, right? And it was doing kind of object detection on the same feed 8 times.
Correct. Yeah. So we had a bunch of vehicles. I think it was playing back with a local file. But the important thing to grasp there is that kind of intro to like what you can do with the DeepStream SDK, so that we could do what we're going to do today.
Yeah, and so now we've got a little bit more structure going on here where it looks like we've got a few modules. And then I think we might have a surprise for our final module or a follow-up video after the final one.
Correct. Yeah. So we are going to continue our pace with making additional videos for each of these modules that you see on the intelligent video analytics with NVIDIA Jetson and Microsoft Azure. And this one is going to, of course, focus on actually deploying essentially the template solution to our Jetson device. And we're going to, instead of running DeepStream on the Metal like we did in the previous video, we're actually going to run it as a containerized workload as part of IoT Edge. And this is going to require that we set up a few backing services within Azure just to facilitate some of what we call modules that will be running alongside the NVIDIA DeepStream SDK. And these will hopefully, as you tune into the rest of these sessions, they'll sort of build on each other to where you'll actually be able to build that full project that we demonstrate on the GitHub page, which is essentially a overview of how to do live object detection with telemetry and data consumption into Microsoft Azure. So we'll be doing some cool stuff like real-time visualizations with Power BI and how to develop your own model and all that sort of thing. So the viewers should be left with kind of this ability to build their own intelligent video analytics pipeline to do whatever they want it to do.
Yeah, and I have already planned this out. I'm gonna order a bunch of cameras, and I'm not doing any climbing. I'm gonna make my 16-year-old nephew climb the 30-foot ladder and install cameras all around my house.
That's smart thinking, and a good way to get that job done. So yes, at the very end of today's content, the next thing, if you are a viewer, you would want to acquire the camera before module 3. Probably you could still get away with it, but it'll be really good opportune time to actually set up those video sources when we get to the end of today's module, if you're planning on doing anything custom.
Okay, and
so
maybe in the notes we can link some parameters for what they should be looking for if they're going to buy cameras to be compatible with this, what functionality it should have, and maybe some example cameras that are good options.
That's a great suggestion. In fact, as we're going through this, we'll have access to the source code stuff here. And as we talk through this, if we do see any areas for improvement, feedback, suggestions, from ourselves or the viewers out there, we can easily incorporate those into this repository. So we would definitely love to have you all help us build this thing out to be something that's easy to follow. So with that said, let's dive into, I guess, module 2. And we'll start with some quick overview of what an IoT Edge deployment is and talk about what the features and benefits of IoT Edge are before we actually get it up and running on our device.
Sweet.
So if you're taking a look there at the module 2 section, if we click into that, you should see up there at the top, we have a section that sort of defines all of the available modules that are going to be going into our deployment. There's a link there that says IoT Edge Deployment for IoT Hub. If you open that in a new window, that should give us a quick little rundown of where this deployment is in fact defined. So that is something that we call a deployment template.json file. And if you sort of click through it, you'll notice that there's these entries for system modules as well as custom modules. If you bring that thing up. And we're going to quickly just sort of go through what each of those are. So if we head back to the README, these will all map to some entry in that actual deployment. But let's kind of start with giving you an overview of what IoT Edge is. It's essentially a container orchestration runtime that also has the ability to communicate telemetry in a high throughput manner back to what we call an Azure IoT Hub. And the way that it accomplishes that is via the two system modules, so the Edge Agent and the Edge Hub. And these require that backing Azure service of an Azure IoT Hub exists in order for them to work. In a nutshell, what the Edge Agent does, it's responsible for essentially pulling down this deployment that will live inside of the IoT Hub and be targeted to a particular device or series of devices. And the Edge Hub will actually be responsible for inter-module communication, so the ability to send messages from one module to another, as well as the outbound communication to the IoT Hub itself.
And we have a question actually asking, what's the difference between IoT Hub and Kubernetes? And I'm guessing this is just in relation to container orchestration. Like, why use IoT Hub to orchestrate your container instead of using Kubernetes?
So it's interesting. So IoT Edge itself, the runtime, if you will, actually can be deployed through Kubernetes. So it is but yet another sort of way to deploy containerized instances of workloads. One of the things that it gives you out the box is a series of first-class SDKs that allow for easy abilities to communicate with additional modules, or if you want to call those containers, that have been orchestrated by the Edge Agent itself. So an example of that would be, say I want to have a module that's responsible for reading temperature, and another one that aggregates that over time to send maybe like a summarized result over a time window. Those first-class SDKs allow me to define something within those modules that the Edge runtime actually sees in the hardware itself to be able to pass those messages between each other. And I'm not saying that that's impossible in a Kubernetes deployment where you could like expose, a service endpoint or something like that to speak between them. This gives you a nice high-throughput MQTT-based transport protocol to actually deliver those messages back and forth to each other. So it's extremely fast, and that is just one example. There's also additional things that it can provide, like offline support, which we'll kind of gloss over a little bit later, in addition to other behaviors. But while they're similar, they're not necessarily the same, and I would argue that the Edge runtime is a bit augmented by those first-class SDKs that support features.
Okay.
So after we get past the Edge Agent and Edge Hub, which are those system modules, and these are generally present in any IoT Edge deployment, we have a series of custom modules that are going to perform a number of different tasks for us. Now these are doing the cool stuff. So if you watched like that overview video in the GitHub repo, it shows us essentially using a security system that's looking at 4 cameras in real time, generating object detection results. That is being produced using the NVIDIA DeepStream SDK, which is essentially our inference pipeline that is both taking in video frames and also applying an inference engine against those frames to produce results. And this is augmented with something called a camera tagging module. Now, you don't actually need this in a deployment. When I was thinking about how I wanted to package this up to end users out there, this thing is actually really, really useful, specifically for obtaining images for use in training a custom object detection model. And we'll see this in the next module. We're actually not going to see this in action today. We will deploy it, but we're not going to touch it essentially until the next video. But in a nutshell, what it lets us do is look at any available RTSP sources on the network. We can obtain images from those, which we can either directly upload into Azure storage or We could also put those in the custom vision AI. And it works in tandem with something called Azure Blob Storage on IoT Edge. Now, what that is if you're familiar with Azure Storage in general, you can think about it like a edge-based version of it. So it runs locally, it stores things, but it can also be configured to do some nice things like store and forward in the instance that you don't actually have outbound network access. So you could think about deploying the solution in a area with closed caption TVs, and maybe those are only available on the local network. It could capture those frames nonetheless, so long as it has access to them, store them on blob storage, and you could then retrieve that device from that network, put it on an external network where it could then mirror that data to an actual Azure storage endpoint.
So we're talking about more like
finally,
OneDrive.
We have this module that we're going to call Deep Stream Analytics that similarly is going to be taking a service that would traditionally live in Microsoft Azure, and we're going to run it at the edge, this time using what's called Azure Stream Analytics, which allows us to write in a SQL-like syntax these queries that can act on time epochs rather easily. So you can say things like, over the last 30 seconds, summarize, or average out this data that we've been seeing coming from this device. And the reason for that is the NVIDIA Deep Stream SDK module itself. Once we put that into action, it can produce object detection results numerous times in a single second. So I've seen on some devices using like the Jetson Xavier NX that it can actually generate like 30 of these in a second. So having something that can sort of filter those down so we don't send all the telemetry to Azure, but maybe an average over, say, 15 seconds or 30 seconds. That's what the Deep Stream Analytics.
So is it all kind of aggregate metrics, or is this like, does it also support sampling where it's just kind of grabbing it at some periodic interval?
You could do either, but the way we're doing it is actually an averaging over. So we look at the results over 15 seconds and we say like, if you saw 2 cars in this location, did you see them over, some threshold amount, like longer than a second? And if you did, we're going to count that as accurate. And then we'll take the max reading that we saw perhaps over that 15-second period, and that becomes the thing that we report. So we know that like in 15 seconds, we saw X amount of people, vehicles, or whatever object it is you're trying to detect.
And I don't think we talked about this the last episode, kind of where we were going with this. And you kind of hinted at that. Do you want to talk about kind of what the end goal is, what kind of metrics we're going to collect and things?
Sure. So we will actually be able to see object detection results. So basically, what the class of the object is and how many. And we're going to utilize that information to build up a series of services in Azure in the later modules that'll do things like allow us the ability to historically analyze those, perhaps even be able to detect anomalies that are coming through that data if we set up custom rules and things like that, as well as being able to visualize those in your real time using services like Power BI. And once you get this up and running, especially if you have like multiple camera feeds, you'll see that this could be employed for a variety of scenarios. In fact, we don't want to lock you to one. If you look at this sample video, we kind of gone with this like home security approach, because I think that that's one that if you were a hobbyist or an enthusiast wanting to follow along with this, that's something you could replicate at home. But the roadmap that we're essentially going to describe here and build out could work essentially for anomaly detection in factories, for, if you wanted to employ this in a city for maybe, counting cars and people in public areas and things like that. We're going to give you that recipe, and not just, we're not going to box you in at any point. In fact, the only thing that this relies on is essentially the Azure services itself, but what you make of it in terms of what objects you want to detect, we'll show you how to turn that into, things that may be of interest to you, how to build those custom models, as well as how to connect this up to various different video input sources and essentially make it your own.
And in our particular case, we're working on detecting people in cars and how many of them over what time, in what location based on a particular camera.
That sounds like what we'll end up with, although I don't want to ruin the excitement for Module 3. But we have an ability to either use a custom vision trained model, so something that you would spend a lot of time developing, or dropping in an academic grade model that can do like 80 objects rather accurately. And that includes people and vehicles as well in there.
Awesome.
And so before you head out on this, I do have some notes here about the pricing. It depends on what you choose here. So for today's module, the only two services that we'll employ are an IoT Hub and an Azure Storage account. And also, even though you won't deploy the Stream Analytics job, you'll technically be using a job that lives on one of my Azure accounts. It will incur a billing of, I think, $1 per device that uses it. And in a later module, we'll actually show you how you can replace this with your own instance of it. But for this particular module, you're going to use my version, and you're going to use your own IoT Hub and your own storage account, which there's actually a free version of the IoT Hub. So some of this you could end up getting this thing built for just a few dollars per month. Even thinking about Azure Storage is relatively cheap. And it'll depend on how much data you upload into it. But I mean, we're talking, you could upload thousands of images before you start hitting, gigs of data, and a gigabyte is pennies. So this will be a rather cheap solution to employ at this point.
Awesome. Yeah, and I mean, you can get free credits and stuff like that too, like if you're new to Azure. So, and
yes,
I suppose you could swap out the Azure bits for other things if you happen to be using other services or on-prem or things like that too.
Depending. So there will be a tight coupling of the IoT Hub since we're employing IoT Edge. And the storage account is also tightly coupled in that those modules underneath the hood use an SDK that specifically talks to Azure Storage. Although the ideas that you learn here, yes, you could certainly build out a very similar infrastructure using services of the same nature, I'm sure, on other platforms.
Sweet.
So the first thing we'll do, now we're going to switch between things that we're going to actually do on the Jetson itself and things we're going to do in what I'm going to refer to as the dev machine, which you can run the dev tools on a Jetson device, and that includes the Nano, but I don't recommend it because you're going to top out resources the minute this deployment goes live. It'll cause like VS Code to choke and stuff on that device if you were to do it, but you can. So the first thing we'll do is install a few tools that usually are not present on default installations of the Jetpack or the OS, if you will, that comes with your Jetson device. And so we'll use, just wait for you to catch up with me here, Eric. We'll go ahead and install those tools, which these are commonplace. We'll use curl and nano. For those of you out there who know how to use VI and stuff like that, you probably don't need to use nano, but I find that this is for those that might not feel comfortable on the terminal or whatever, it's a nice intuitive interface for editing files and things like that. So that'll be your choice there, essentially. But,
okay, so we've rotated over here to the Jetson. If I look like I'm looking away, it's because I kind of have a second monitor over here that is the Jetson. And I'm pushing that to the stream now. So, all right, so we need to install some stuff. And I'm going to say no to Nano. I'm a Vim person. So, all right.
I get it. I just I'll go on record for those of you, if you feel that it's not inclusive, if we're not running Vim or Emacs, even, I don't want to leave y'all out here. This is just the one, I go with Nano because I find, sometimes we have people that attend these workshops of ours and they've never seen a terminal. You ask them, open the terminal and they don't know. Nano, you don't have to think to use it. If you can use the character keys, the backslash, it's like opening a Word document almost.
All right.
It just works.
I guess I should open this up in here. So I'm not saying anything like nobody has to use Vim. I just happen to be very productive in Vim, so I feel more comfortable. I don't know the hotkeys to get in and out of Nano because I never use it. So, and Yeah, use whatever you're productive in. Don't let anybody editor shame you. All right.
And so, yeah, the commands that you're now running are for installing the actual IoT Edge runtime. Now, what's cool about Microsoft is this thing is distributed as a Debian package, which is sweet because simply by adding in the appropriate repository and the source list and the PGP key for that, it's as easy as an apt get install to get it on your machine. So those are the steps that Erik is following through with right now.
This is the part where Paul pops my local network because I'm just randomly copying in shell stuff to run. You could obscure it even more if you did a curl bin bash.
This is true. I hope that you're trusting me because you see Microsoft in those Microsoft.com and those package lists and public key URLs. But yes, this is an officially released package from Microsoft. And it's actually built off of an open source project. So believe it or not, IoT Edge is open source and developed on GitHub, believe it or not, and is built on some cool technologies. There is, so it's actually comprised of this runtime and a security daemon, and that security daemon is actually written in Rust, believe it or not.
Nice.
So that's cool. And the runtime itself is capable of orchestrating any OCI compatible container runtime. So Microsoft officially supports what Moby, which is the open source version of Docker, what we call Docker, but it'll work with Docker. And in the case of the Jetson hardware, we're actually going to be interacting with something called NVIDIA Docker. It's a special form of Docker that can give you access to the GPU and things like that.
Huh.
So you just got the excellent message that we have documented here. So it's going to tell you essentially what you should probably do next, but it doesn't tell you how. So it tells you, update this configuration file, and once you do that, you will need to restart IoT Edge. So this is a chicken egg problem. We have to have a thing that we can use to register this. So you're taking a look at that file now, and we're almost there. We just need to go and deploy an IoT Hub within Azure, then use that to create an IoT Edge device, and that will give us a key that we can essentially put in this configuration and allow it to authenticate with that service.
All right, so let's switch back over to my primary desktop. And then, all right, we need to create a new resource.
Correct. And let me make sure I'm following you on this screen. I might be looking at the wrong one there. Yes, so we're going to look at, we will want to look at creating an IoT Hub. So if you search there for new resources, search for IoT Hub, you should get a hit. And we'll go ahead and click create. Now, in our documentation, we've actually linked to the instructions for doing this in the Microsoft Docs. It's actually so easy, we're just going to do it. But it is there, so if you did want to follow along with something that's a little more prescriptive, those are linked in the Module 2.2 section. So in your while you're creating that instance, I do apologize, this is a little blurry on my screen. What's going to be important to note there is the location that you deploy to. You'll likely want that to be something near to your locale, wherever that happens to be.
That's East US. All right.
And East US is a really good choice. Those folks always seem to have the latest and greatest. It's like,
except I have noticed for the video services, for cognitive services, if you want automatic captioning of your videos, it's only in West right now. So West got it first.
That's like the first time I've heard of East not getting the first pick. That's interesting and good to know. I see Brian Kettleson is in the chat. That's cool. He's famous, I've heard.
Brian and I'll get to be doing this a week from today too. We're redoing our Kubernetes to Edge Device stuff where we control a robotic arm.
Excellent. Now I see you're in the pricing section here. You will want to choose this according to what you expect to be produced by your device. Now I've got that filter configured to send one message every 15 seconds. So if we did the math on that, it's something like, that's 4 messages per minute and minutes in a day.
Oh, you're going to make me do math now?
Would be 4 times 1440. So that's 5,760. So you know what's cool about this is the free tier gives you 8,000 messages per day. So this solution will run on the free tier. But I'm going to suggest, because you can, Eric, I know you might have special privileges on your account here. Let's roll with a standard, just because. It'll give us high throughput. We won't have to worry about any message limits. Not that you should, but we definitely won't.
This is one of those things we jokingly call cloud privilege, where we just get to spin up what we want mostly. All right, so we're going with standard 400,000 messages a day. Any advanced settings or anything?
I don't think so. The only other thing I know in the previous setting, you might have had to create a resource group.
Yeah, I did.
That would be, yeah, let's point that out real quick just for viewers. So and what a resource group is in Azure, if you're not familiar, is just a logical grouping of resources. It's like if we know we're going to build this IoT Hub and a storage container today, we probably want to put them in the same place. And so the resource group will allow us to have a logical way to get to both of those resources through the Azure portal. And yeah, I would say that that's it. You've done everything. So we can go ahead and create that. And it's a good choice of name. So he's called his hub Intelligent Video.
We had somebody ask if we can walk through a little bit about the math we were doing to calculate whether or not the free tier would work for someone.
So free tier gives you 8,000 messages per day. I know that our Deep Stream Analytics module that we hinted at earlier sends messages once every 15 seconds. So that would be 4 times per minute. And there are 1,440 minutes in a day. So 4 times 1,440 gives us a grand total of 5,760 messages sent over a 24-hour period.
So that would technically fit in the free tier. We're just using standard because we can.
Yes. Yes, precisely. And if you were wanting to do this for production, of course, you probably would want to use something like standard, just due to the, it'll get higher ability for it to receive updates and things like that.
Yeah, typically that's some of the stuff. A common theme you see in the free tiers is they don't get as many IOPS and things like that. They're lower priority, things like that across services. So that's something to look out for if you're going to go production with it, is to make sure you understand.
Oh, sorry. There was a delay there. I didn't mean to talk over you.
So, all right.
But yeah, I was going to say there, when there's an outage or, like what we saw with COVID, generally if the Azure data centers ever hit capacity, the first things to go are the free tier instances of things. That's something to be aware of as well.
All right.
So we'll wait for that to complete. It should take just a few moments.
Do we want to go ahead and create the storage account while we're waiting for this?
No, we're going to do these in order how they're listed in the instructions. So we'll just give that a moment. It shouldn't take too long. And then what we'll do once that's deployed, we're actually going to create an IoT Edge device. We'll actually register one. That will give us a connection string and key that we can use to register it in that configuration file that we were just looking at.
All right, we are up, except we're not in an active state.
Ah, yes, this can take a few moments. I've seen this, as long as 5 minutes. So I'm glad you pointed that out. but should wake up any moment. And if you do encounter this, it is suggested that you do a full refresh on the page to see when that active state gets removed. This just means it's still in a provisioning status. Even though it's been stood up, there's a few last minute things that need to be configured before it goes live. And we'll just sit tight here for a moment while we wait for that to come up. And this will be the only thing I think we're going to have to wait too long for. Everything else should be.
So
Martha,
I guess while we're waiting for this to come up, let's talk a little bit about like what's the end goal for this particular stream. What are we trying to achieve?
So at the end of this stream, we will have deployed the baseline template that contains all of the modules that we described earlier at the beginning of module 2. And it's going to be ripe for customization at that point. In fact, if you have access to a USB camera or a RTSP video stream, at the end of this point, we're going to show you where you would customize that, and we'll actually connect to an RTSP capable camera that's pointed at me.
Yeah,
at the end of this.
we can snoop on that right now here.
Yes, that's me live on a whole nother camera, and hopefully we're going to get that working with a. So when this thing ships down, it's going to use a custom Vision AI model for the object detection, which will work to some degree of accuracy, depending on how well it looks. But this is looking like it's going to work, so I'm happy about that. So yeah, we're going to connect that camera that Erik had on screen to our deep stream workload running as an IoT Edge module. Is essentially what will happen.
Now that's a good question. I just had VLC open. Let's see. It wasn't live at the time.
Oh, I gotcha. Yeah, it seemed frozen there for a sec.
Yeah, we're gonna let it load here and see whether it's still working. We're gonna put my network to the test live. I've got live streaming of all of this going out, and then yep, now it's live.
Yay! You see me twice probably, which is weird.
And I can hear myself out your speaker and through the camera.
Lovely. Another thing to talk about, I guess, while this thing is spinning up is what is the IoT Hub? What does it give us? So this is, if you're familiar with event hubs in Azure, they're like high throughput ingestion points that you can connect. In the case of event hubs, they have you can connect the Kafka protocol to it and stuff like that. What this is going to do is when we instrument the Edge runtime on our device, it's going to speak to this and send messages up to this IoT Hub for processing. And that's going to essentially be, we're talking a throughput of up to 1 million events per second. And it does that over AMQP or MQTT protocol, depending on how you've configured Edge, which I believe by default, it's going to send those messages over AMQP. Could be wrong about that, but it does depend on how it is configured. And the other thing that it gives you is the ability to actually register devices. So that's what we're waiting for it to become active for, is the IoT Hub adds these extra features to securely register the devices that are able to communicate over that high throughput transmission layer. So essentially, it knows of devices that it can talk to, and that's where you're going to see why we're going to actually update that configuration file, is because we want to securely authenticate our Edge runtime instance to the IoT Hub to gather all of our telemetry. So hopefully that's clear. That sure has taken a little longer than I expected to come up. May not function properly. Okay. What happens if we do a Shift F5 on that, Erik? The full reload.
Ah, and it's active. Apparently, refresh doesn't actually mean refresh.
Oh, I'm sorry. I sort of alluded to that. I guess I should have called more attention when I was saying refresh.
You meant
And
the
of course,
browser.
the big refresh button there, you assumed I was talking about that. Yes.
Yeah. Okay.
Don't trust it.
Now we look like we're good.
So if you scroll down on the left, there's a section called IoT Edge.
IoT devices. There we
The
go.
IoT
IoT Edge.
devices, and don't be confused with those. Those are non-Edge based devices. So remember, Edge is special in that it has these first-class SDKs. And select Edge, and then we will click on Add an IoT Edge Device.
Add an IoT Edge Device.
Now, the naming convention I use, I have so many of these NVIDIA devices. I usually give them what they are. It's like Jetson Nano and then a number, which I'll usually stick on the device. So like Jetson Nano yeah, exactly.
Minus 24 because you sent me one of yours.
But you can put whatever you want here. Oh yeah, so you received device number 24.
I did.
Nice. So we can do that.
All right, do we?
Or another option would be to use the host name of your device. So
I think it's just Jetson Nano. So
that works. And then we can click save on there.
Okay. Are we using a symmetric key or self-signed cert?
We're going to use the auto-generated symmetric key.
Okay.
Because it's easier that way. But yes, if you were going to prod, you can bring your own self-signed X509s.
Okay. And here's our Jetson Nano.
And now that you've got that registered, you can click on the device itself. So if you click on that box there, this will give you access to the keys. So you see there's that primary connection string and secondary connection string. Go ahead and copy the primary key for one of those. Either will work. Okay. I'm sorry, you don't want to copy the entire connection string, not the key. You do want to call that out.
Oh, okay. Connection string.
Yeah, and that's confusing because, yeah, saying one thing when I meant another. And then if you scroll down, you'll see, as I was mentioning, the Edge Agent and Edge Hub are the system modules that are part of every deployment. And so by default, when the Edge runtime wakes up, it is going to pull a configuration or deployment that consists of just those two modules.
Okay. I'm just looking over here for, IP address. Because we're going to need to SSH into it to copy that, I'm sure.
Not necessarily. So, yes. So this would definitely be something you would want to either, if you were on the device itself, you could visit the Azure portal and get the key on your Jetson device for ease of copy paste. Or, as Eric's doing here, he's going to shell into the device from his dev machine and edit it from there.
I was going to use WSL, but I like to update things. So apparently in one of I'm on the fast ring. I guess I need to update my kernel.
Well, a lot of people forget SSH is built into Windows now.
Yeah.
You run it from the command prompt.
Oh, looks like we need some updates too. Okay.
We'll get to those.
All right. We need.
But yes, you should be able to edit that. It's in
IoT
Edge.
Yep. Okay. Now, what are we looking for in here?
So, and just for those following along, I am reading this off of the actual instructions here. You're going to scroll down until you see a section that says provisioning manual. It should be up at the top. Not the very, very top, but nearby.
All right. Manual. Supported mode.
Next one.
There we go.
Next one, yeah, that one right there. And see where it says add device connection string here? You will paste in that connection string that we just acquired from Azure right here. That's the one. And exit out. And then you can restart the IoT Edge service with sudo service IoT Edge, all one word, restart, or systemctl. See, I'm old school. We just call it,
Doesn't matter how long you've been a Linux person, you will do this. All right.
And that's right. Systemctl switches out the action noun syntax. If you were using service, it's IoT Edge restart. And if you're using systemctl, it's restart to IoT Edge.
Okay.
Lol.
So now I think
gets you every time.
now I think we're good.
So agreed. I think we are good. Now that is going to start spinning up, and you can check the status. So if you do like since we're being friendly with systemctl, let's do a systemctl status IoT Edge. And this is a good sign-ish. So you'll see it's saying active running. That's good. You know what is scary though is it's saying updating identity for module edge agent could not pull. That's interesting. Caused by could not pull image Microsoft. That's okay. We can ignore that for now. I think it will eventually pull it. Also, in that, if you go back to the module 2 documentation, I've got the syntax for looking at the daemon logs if you're wanting to use journal CTL.
All right. So
Hopefully.
let's take a look at the daemon logs.
See, it's just a false alarm. It's saying error pulling, and now it's saying pulling the image down there at the bottom. So I would say, looks to me like life is good.
Maybe failing.
Oh, that's throwing that error again. Is that device online? It's got to be, right?
Let's see. Could not pull. Do we know what this full image is, and we can try to Docker pull it?
Yes. So I'll show you where to obtain that. So if you go back to the Azure portal where we were, you can actually see the default deployment that it's applied if you click up there on set modules up at the top, and then go into review create, skip all the way to review create. And if you look through here, you'll see a deployment that looks similar to the one we were originally looking at.
There we go.
And there's your image. So if you try to explicitly pull that, and that actually might be the reason why, is because it is
permission denied.
Sudo. We're not in the Docker user group yet. We'll set that up in the next steps, but that should do it.
Okay, so probably in the example code here, this would probably still keep failing up until the point we put ourselves in that group, huh?
Perhaps, yeah. So the IoT Edge, well, no, IoT Edge is added into the group. What I think it is, if you actually look at our deployment, actually that doesn't make sense. That should totally be pulling. So I'm looking.
And do we want to pull the hub too?
Yes.
Okay. So in theory, people shouldn't need to do this manually.
So what happens when you install IoT Edge? It adds the IoT Edge user to the Docker user group.
And we haven't.
But that's only on the next session. So because we're
right.
in the same session, it didn't have the permissions yet. So if you were to reboot the system after doing this, it would get it.
And I mean,
that's it.
Yeah. I was gonna say we could do that, but then we're getting the screen sharing and everything. That's kind of a tricky thing for us right now with this like multiple machine getting it on the same feed. So
try there's another one there, sudo IoT Edge list. So there is a number of the IoT Edge binary that ships has a number of tools in it as well for checking things, and so that is a good status. So the fact that the Edge agent is up and running gives me some confidence that it will eventually pull the Edge Hub.
Okay. No, we got the hub.
Oh, perfect. Okay, so we did get that. Sorry, I was looking at your screen.
We did.
Like response. Yeah, sorry.
It should go. All right. We'll let that run.
And so now the next thing we're going to do, so Edge is up and running. It has been configured. We're now in section 2.3. This is where we're going to start making a home for the sample configurations to live on the device. So these steps will actually be followed on the Nano itself, or your Jetson device, whichever one that happens to be.
Okay, so we need to sudo do miscellaneous storage And then we need to I'm like typing sideways here.
Now, that convention of using a /data directory is interesting because if you were ever to want to run this on like a GPU accelerated Azure VM, the /data directory is important because it persists across reboots for a VM in Azure. That is actually not guaranteed. So folders that you create on temporal storage are not guaranteed to persist, although if you do put something in the /data directory, it will. So we're just kind of using that convention there. I'm sure Brian can chime in on that, why it might be useful. And so now what Erik is doing is cloning the GitHub repo itself, essentially into that, that data/mist/storage directory. And why we're doing it like that, it's a really easy way for me to ship down everything that you need for this stuff to work. Because it's a lot. It is. If you were to excavate this, there's a number of different configurations to do a lot of things. The command he's typing in right now, the xhost local IoT Edge, is going to give his current session, is going to allow the IoT Edge user to be able to access the X11 socket from a container. So it actually can't speak to that socket unless it's been granted permissions. And that would not be persistent, but because he's editing this file here, so if you edit /etsy/profile, oh, whoops, you're in the wrong, you're in etsy/pro, sorry. So he's going to do /etsy/profile. Yeah, it looked a little barren there. And just anywhere in here, I would advise doing it at the top. You might have a different standard. This will make that persist. So anything that's in etsy/profile will essentially run whenever a new session is started.
Why is that?
It's got a sudo. Yeah.
Yeah. So you have your own profile. So in theory, we could also do our own. We could put it in our bash RC, right? Like, there's lots of places we could put this on our own session. The Etsy profile is going to do this for every user.
Correct. And if you don't do this, your deep stream configurations are going to start barking at you like unable to find display or something to that effect. And this very last step is going to add your current user. So it's going to add, in this case, Erik, to the Docker user group. Now, what this means is type Docker real quick, Erik. And enter. You'll notice Erik now has access to run Docker, but you didn't before. Remember, you had to run that as sudo?
Right.
So that fixed that. I always thought you had to exit the session for that to take effect, but looks like that worked. So we're almost near the end. So you have set up those dependencies, and there's a config that's just waiting there to work. We just have one other thing to set up, this blob storage module. So if you remember earlier, we were talking about this camera tagging module that you can use for gathering samples. It needs some configuration in order to work. And that we're going to do over on our dev machine.
All right, so we're going to do this on my desktop. All right, so, and we're going to do this. Do we need WSL, or are we going to do this right on Windows?
Doesn't matter. Either is fine. Yeah, it doesn't matter.
Well, let's go with PowerShell, and you can watch me fumble because I have much more experience on Linux than I do Windows. Just because I don't want to take up time while I update the kernel for WSL. All right. I mean, that only takes a second.
Yeah, really all you're going to do here is do a git clone. We're essentially going to clone that same repository to your dev machine.
All right, let's do it. I know that I have a code directory here. Yeah, I have a code directory in here. We'll just...
Oh, curls in Windows now too? I was just looking at the chat messages. Yes. Yes. That's awesome. So me, I always throw things in like a source directory, whatever your convention happens to be, go with that. And now you're going to want to open that directory in Visual Studio Code. So you could do the code dot trick or yes, or code with the folder name. So what Erik has done is opened up that folder immediately in VS Code. Similarly, you could do file open folder if you weren't as adept at the command line. So the first thing we're going to do is there's a folder in there called deployment-IoT Hub. And the reason it's named that is we're going to build this to work with an IoT Hub, hence why we deployed one. There's also a service called IoT Central that this could work with. I'm not going to talk about that now, but that's why there's two. In that directory, you're going to go ahead and create a file called .env. And you will paste in the contents of that are coming from the next steps in our repo, so container, registry name, et cetera, et cetera, et cetera.
And a fun little aside here on the Linux side of things, a really cool tool is called DirtEnds, which allows you to create a .envrc in a directory, and when you cd into it, it will execute it. So these environment variables would be set, and then when you cd out of the directory, it puts them back to what they were before, which is amazing for if you have like a project that's talking to one database and another directory needs to talk to something else.
That's cool. So in this case, this is actually going to do some find and replace in our deployment template, the thing we looked at the very beginning. So you can leave everything as is. We're going to skip container registry name because unless you're building modules from source, you don't really need to do that. We're going to pull these from public places. But we do need to generate a local storage account key. Now what this is the key that the local blob storage module uses for HTTP communication from another module. So the easiest way to generate one of these is just go to generate plus, and it'll spit out a key for you. And you probably don't want to use this for like secure things that are going to be externally facing. This key is actually not that important in terms of if it were ever compromised. Is essentially just the key to access the API that the blob storage module surfaces. So someone would have to be a host on your machine in the first place and know a container was running and then use that key. So it's not, I guess what I'm trying to say here, this is not the type of key that you have to guard as succinctly as you would like a root user password or something like that. This is it's just an API key essentially.
And we're just dropping that under the local storage account key?
Correct. And then what we need to do is for the cloud storage connection string, that's one of those chicken egg things. We actually have to have a service that exists in Azure for us to do that. So what we're going to do for that one, we're going to follow these instructions to create a storage account. So we'll head back into Azure, and you'll probably want to throw this in the same resource group that you did before. So I'll try to walk you through this, Erik, so you don't have to go back and forth too much. The storage, I'll usually do storage blob. I'll usually get you the one we want. There's a lot of storage services. It's like, yeah, if you just search, there's one, storage account blob queue file. That'll do it.
Right, where is it?
Right there at the top. Storage account, yep.
Yeah, sometimes too much stuff comes up even in the marketplace and you can't do what you want.
Yeah, if you type storage, you're going to get hit, and it's not one of the first results. I'll spoil that surprise for you.
Okay.
And so from here, yeah, give it a name.
What? Jetson Nano. Okay.
And you can actually give this, so we're down there where it says cool or hot storage. You can actually set this to be cool, which will make it cheaper, because this is just archival data.
Do we want storage v2? Do we want blob? What do we need here?
Oh, great question. Let's see. What do we want? Oh, what was the default option there? I'm sorry.
It was storage v2.
Yeah, let's just go with storage v2.
Okay. And cool and standard performance good enough for us, or do we need premium?
Standard is fine.
All right. create.
I need to update that. That documentation is missing some steps. So I will update that. So I'm glad we uncovered that. But we'll get through this. Don't worry.
I actually find little mistakes along the way actually super beneficial, because every time there's documentation or tutorials, it's always the golden path, right? And then you run into one of these little things and you're like, well, I don't know how to fix that. Where do I look to figure out what that error is?
Happy accidents, we call them. And the thing too I like about this this documentation is, see, this video that we're recording right now is going to be on the GitHub repo. So not only will we know that it works, we'll have video evidence that we tested it. Yay. You never see that in repos. Prove to me that this works. Sure, roll the tape.
Until both the repo and the videos are out of date, like documentation or comments.
So down here, you're going to want to create a new storage container for your service. So if you actually scroll down where it says containers, click the plus there, and we'll add a new one. And name this very specifically: camera tagging module cloud, all one word.
Camera tagging module cloud.
And that's because it matches up with one of the entries in our env file. If you saw, our destination storage name actually maps to that.
Right.
Now, the camera tagging module local, technically you can give it any name because the storage module will create it if it doesn't exist. That's going to be the local instance. That's going to mirror to this cloud instance.
And we're going to make this private?
Oh, yeah. Yeah, make that baby private, because examples of what I've done with this is you can actually automate this module to take images every X seconds. And I think I dumped 6,000 images from my home cameras. You don't want that being public. That's a terrible idea.
Although technically,
and stuff like no one wants to see that. Okay?
Technically, your camera is public right now. Anybody who was paying attention when I opened VLC could just sit there and just watch.
That one camera is, in fact, I didn't even know. Sorry to make an aside. I didn't even know that port forwarding was disabled on my router until I tried opening the port for this camera. Because I don't open ports for anything. If I want to see my cameras, I can VPN into the home VPN server and look at them that way. If you're gonna do this stuff, I will tell you, never expose your cameras on the network like we have done and showed so far. The only reason we're doing that is to demonstrate that yes, it does work on public RTSP streams. Sorry, but we had to mention that. So you've got that set up, and now all you need to do is obtain the key for that. So if you actually click on that container, go into it, there should be, I believe, under why does that not look right? It should be, oh, I'm sorry, we don't want the keys for the container, we want the keys for the storage account itself. So back out to the, yeah, okay. Sorry.
Where's our storage?
Easy mistake. Easy mistake. So yeah, if you go down there to access keys under settings,
there we go.
And then go ahead and grab your key one. No, sorry, the connection string. I almost did it again. And then grab that and paste that thing in there. Cool.
And now that is public, where anybody can just get into that.
This is hardly a security concern at this point. Yes, you can upload data into your storage account. Those who have copied the key. Brian, don't do that to us, please.
We had somebody ask what we're developing here. So Paul works on IoT Edge or work with the IoT Edge teams, and he recently sent me one of the Jetson Nano embedded devices. So we started with kind of an intro of the device last stream, and we're working our way over the course of like 5 streams to building an intelligent video security system where we can detect objects and people in cars and things like that on the cameras, and then collect analytics over time and maybe do some anomaly detection as like a stretch goal to be able to see dashboards and stuff of how many people are walking by your house or in your backyard or something.
So yeah, intelligent video analytics at the edge, in short form. Yeah, but yes, to all of those things that Erik said, plus more. So now what you have done, that ENV is special, and I'm going to explain the magic of it all now. Because you have filled out the ENV, it will actually, if you click on that deployment.template underneath there, it will actually replace all those variables within there that are preceded with $signs. You see that $sign, container, registry username, registry name. You'll notice that there's map2.env variables. But if you scroll even further down, the ones that we were specifically setting up were for the camera tagging module. So you'll see here, it's going to have an entry a little bit further down for local storage account name and storage account key. That was that key we generated from Gen Plus. And then the Azure Blob Storage on Edge is going to know what keys it's going to configure itself with, as well as the ability to speak to that backing Azure storage connection string that we just copied from Azure. So it's going to like essentially token replace those.
All right.
So to do that, I don't think you've installed the prerequisite plugin, and that's okay. The prerequisites are defined. You don't have to do this, Erik. They are defined in the main README of this project. If you scroll down to the very bottom, that will also answer your question on what we're building. But I will tell you how to do it. I'll tell you the fastest way to do it too. So if you hit,
we had a question that asked if we're planning to extract text from images. I don't think we are in this particular series, but I'm sure that's types of stuff that we could do in the future.
Yes, we could certainly get close to that. We're going to be doing object detection specifically. So here in that section 2.5 is where we're at, Erik. You're going to this is going to assume that you already have the IoT Edge tools installed. Let me go ahead. There's a number of ways to do this. You can install it through Visual Studio Code, or I'll send you the link, and you can send this to other folks if they want to just be aware. We're going to use this thing called the Azure IoT Tools. Yep, that's the one. And it is like, this is one of those interesting plugins for VS Code in that it's actually a whole bunch of plugins in one. It brings in all the stuff you need to do IoT Edge Dev. And you can ignore it. Docker's obviously running. I don't know what it's saying.
Docker's running on the... Oh, wait. Is Docker running on my desktop right now?
Oh, that's why. Yeah, you can ignore that because it doesn't matter. We're not doing Docker on your dev machine. Sorry, I thought you were on the Nano for a sec there. But yeah, that's safe. That's chill. So now that you have that plugin installed, you can do this trick, the command palette. So you're going to do Control-Shift-P. And first thing we want to do is set the target platform for this solution. Okay. So go ahead and, yes. Yeah, if we head back here, and if you type in Azure IoT Edge, Azure space IoT Edge, colon, one of these should say set default target platform. Okay. Yeah, that one. And choose ARM64V8. Now, fun fact, you can also change that down at the bottom of your IDE. You'll see it says ARM64V8. That's actually a drop-down. You can also change it from there.
Oh, perfect. Sure, make me do it the hard way, Paul.
I don't think it's there until you set it the first time. Maybe it was, and I just
I don't think it was either. I think this probably adds something to the project to specify.
And you know what? As you'll find when you read my documentation, anytime I can avoid using a screenshot due to staleness and all those other reasons, I'll go with the non-screenshot ways. I don't know how else to say. The thing down at the bottom left in between, depending on whether you installed this thing or that thing. So the other thing we'll do is select your IoT Hub. Now this is cool. So if you do Control-Shift-P, and this time do Azure space IoT Hub. And one of those should be select IoT Hub. That's the one.
You are not
signed in.
Sign in.
Sign in. Yeah. And that should
Oh yeah.
Which,
And if you haven't seen this, this is amazing. I love Edge for this. The fact that I have multiple, my personal profile and my work profile, and I can switch between them.
I'm feeling good here. I think we're going to do this in the 90-minute mark.
So let's see.
I really do.
Am I logged in?
Are you logged in? Let's try that again.
It doesn't seem to.
Oh, did it not? Yeah, because it's going to make you authenticate against your Azure subscription.
Which it is not doing at the moment.
When it loads. Yeah, this is important. We got to get this part up and running.
Let's see.
What the?
Yeah, this is weird. All right, let's just stop that for a second. Let's see if we can do this again. What's it doing?
It's a good question. I don't know what it's doing. Maybe it already set it up. There's no way, though. It should give you a drop down. Well, maybe you only have one IoT hub. Expand that IoT hub down at the bottom. Oh, so still waiting for Azure sign-in. Huh. Yeah. Now, why would it not let you sign in? You don't have an ad blocker or anything like that? That should.
No. And the odd thing is it's hitting this localhost address. I don't think I've ever noticed that before.
No, same. Go ahead and exit that.
Let's
try to let's try to redo it. And if not, there's another way you can get around this. Okay. So Eric has just restarted VS Code and basically going to do the same thing again, I think, here.
Let's ignore that. Okay. Now let's see if we can log in again. Sign in.
Okay.
There we go.
You can't explain that. We literally did the same thing twice. That's the definition of, but we got different results, so it's not insane.
Yeah, and I mean, it's quite possible I had like this update pending here too, that it's quite possible when I updated code that something got fixed. All right, so
my friend, you didn't warn me that you were living on the edge.
I am. Hey, feel lucky that I'm running this in regular code because I have insiders on here too.
All of a sudden, everything that I thought was going to work today is not working. I wonder why.
Brian's in the chat. Ask him how many times I've updated to like the most recent kernel and just before needing to be on meetings and things that I need VPN for. I'm patching kernel modules for VPN so that
You do it to yourself, Eric.
I do
it to yourself.
And you'd think I'd learn.
It's like, I did that the other day. After build, you get the notification. Do you want to run the insider's version of Windows? No, I'm smarter than that. I will only do that inside of Hyper-V. But then you start to realize you can't use Whistle 2 unless you do it. And so then I succumb. And here we are.
Yeah, and see...
You know what? This round of Windows Update has been really good, though. I will say that. We haven't had the usual, bricked machines or things like that. This was a good time around. I'm not going to say there was 0 accounts of that, but this was a good time around.
All right. See, this is how living on the edge we are. We are live streaming, and I'm updating Docker while we're live streaming, because why not?
Well, and that's the thing, too. This isn't fake, right? Like, you would think this live stream would be like, oh, yeah, Erik and Paul, like, realized this worked before they did it. Yeah. We don't know. We're fairly certain it'll work, but we don't know.
Okay, so I think what this looks like we're selected. So
yes,
there we go.
That's
Here's
the
our
one.
IoT Hub here. Oh, yep. Here's our device modules,
and you can see the modules that are running on it. Yes, that thing is cool.
Perfect.
So now, because you're connected to the IoT Hub, we can actually ship a deployment straight from VS Code to your Jetson device, and it doesn't matter where in the world it is, so long as it has external access to the internet, outbound access, world access, as they call it. So from here, to do that, you will right-click that deployment.template file.
Right-click.
And generate IoT Hub deployment all the way down at the bottom. It was there. I don't know why it's not there now. Try again.
There we go.
Yep, generate IoT Edge deployment manifest. And see, it made a new folder called config that wasn't there before. Bust that thing open, and you'll see your deployment template is now a deployment.arm64v8. And it should have, let me double check this. It should have filled in the blanks for those E and V variables. It did. It did. I'm so happy because I was scared that it wouldn't. And now this is where it gets really easy. To ship this to your device, right-click that file, the one you're currently on, the deployment ARM64v8, and do a single device. Create deployment for single device, and throw it on your Jetson Nano. Now, this is going to pull like gigs of containers, because like just the deep stream container itself is like 2 gigs. Are you on Wi-Fi or jacked in with that Jetson Nano?
The Jetson Nano is on Wi-Fi. I do have pretty good Wi-Fi network here, and I have 500 meg connection in each direction. So with any luck, it will happen quickly.
All right, let's. We'll see what happens. That sounds fast enough. That should do it. So yeah, it's gonna go to work. It's gonna get that deployment, and it's gonna start doing that. Now we can do some things in the meantime while it's doing that, because this will take a while. Let's do a few things. One, let's go ahead back to your Azure portal, and remember where we're showing you your current deployment, and it had only Edge Agent and Edge Hub. You're gonna see a whole bunch more things there.
Wait, we wanted to go into this IoT Hub.
That's the one.
And now what are we looking for?
We'll go to IoT Edge, and we'll look for the Jetson Nano device. And click on that. And so it should tell you now that it has a new deployment. So if you scroll down, provided that the Nano picked it up, which it should have. So this will...
Oh, there we go. Oh, yep. Here we go.
Yeah. And so those will start to light up as the container images for those respective modules are pulled. It will then start to tell you that those are running.
I got you over here in the status column.
And you know, to sort of revisit that question earlier, why wouldn't you just use Kubernetes for something like this? Because all these management features and the first-class SDKs. I know that's kind of where I was specifying some differentiation. But there's a world of services around these where you can monitor the health of your hub. You can monitor the health of devices at scale with the Edge IoT Edge Security Center. There's a lot of benefits you get simply by just, if you're throwing it in to an IoT hub, you get a lot of ability to maintain and develop, for the life cycle of your solution. So while those containers are pooling, let's jump ahead of the game and talk about section 2.6, which is the last section for today. And this is the customizing the sample deployment. And when I wrote this, I realized I can't tell you how to customize this because I don't know what you, the viewer, wants to do. I can tell you how, and then it's up to you to actually do those customizations. So if you head over to back to the GitHub repo, we're in module 2.6. Here's a few things to be aware of. So on the Jetson device itself, Erik cloned this repo to it. And if you were to navigate into this directory, this /data/mist/storage/super long intelligent video analytics with, you can symlink that if you don't like the name. I'll just put that out there. And go into services/deepstream/configs. You will find a bunch of sample configurations. Now, by default, the one that is shipped in this deployment is going to reference the dsconfig custom vision AI.txt. Why that is, if Erik was to, Erik, if you open the VS Code instance and we look at that deployment template, and let's look at the template because it's easier to read it when it sort of minimizes the job or the JSON when you actually create the config. So let's do, we'll look at the template. And if you go to the NVIDIA DeepStream SDK module, which I think is higher up a little bit. You'll notice a few things here. So right there. So notice that the entry point is pointing at dsconfig custom vision ai.txt. And if you scroll a little bit further down, you'll see the current working directory is that long directory I just spelled out. So that data/mis/storage/deepstream configs. That's the config it's going to use by default. So when all those modules download, pull, and wake up and start running their workload, they're going to use that configuration. So if you want to modify that configuration to use your video input sources, which could be cameras or RTSP streams. We discussed how to do those things. We didn't necessarily show it, but on our previous streams, if you were to go look at module 1 and watch the associated video, we do show how to do that. We're going to do that, but this again depends on who you are and what you want to do. So if you know at this point, you're like, hey, I think this project that Erik and Paul are building is cool. I want to go forward with a custom vision model that I developed myself. I want to try myself. Then don't change anything just yet. If you know you want to use an academic grade model, so if we head back to the GitHub README, you'll notice there are two other ones. There's dsconfig yellow v3 and dsconfig yellow v3 tiny. Those are academic grade models that have been trained on thousands upon thousands of images and detect 80 different unique objects. The YOLO v3 instance is for more resource-intensive hardware, so like the Jetson Xavier line. If you were using a Jetson Nano, it's highly advised you use tiny. And the tiny denotation essentially means developed to run on memory-constrained device. Is sort of what that implies.
Yep. Paul cheaped out and sent me a Nano.
Next time when we get our budget, I'll try to look into getting a $600 device to you next time. Actually, I think the new one, the Jetson Xavier NX, is like $400, and it's the power of a Xavier. So.
Yeah, that thing is sweet. I was half tempted to buy one personally.
So, trade in your Xbox One or your PlayStation 4, not at GameStop, somewhere where it'll give you actual value of money, and you could maybe trade up to something like that. Now, each of these samples, you're going to look at them and you're going to think, like when you see this thing actually spin up on Erik's machine. In fact, Erik, if you don't mind, if you just monitor it to see if you see a window pop up at any point on the Nano device, then we'll know it's up and running. You're going to see that it's going to be consuming a stream from Big Buck Bunny. And there's a reason for that. We alluded to this on the last video. Big Buck Bunny is the only publicly accessible, reliable RTSP stream on the entire internet. I will hang my reputation on that. If you can find another one, we'll use it. But I've been a part of numerous projects where they try to use a public RTSP stream for test, and the longest they generally last is like a month. So you will see this thing spin up. It will be running Big Buck Bunny, and that config does what it sounds like it says. So it will be running a custom vision AI model against that RTSP stream. And then the second reason why I've used Big Buck Bunny, not only that it's the only RTSP stream, is that the coolest way to use these things, in my opinion, like you could use a locally, like a USB connected camera, but that doesn't really scale. The coolest way to use these things is with network connected cameras in your local environment that you have access to. So it'll make it really easy for us to just change the URL from Big Buck Bunny to, say, that camera we were looking at of me earlier, and should just work. So for you to make those edits, you would open Nano or VI and edit that respective config file, and restart the DeepStream container after you make those edits. Make sure it comes back up running, and do that until you can get your own video sources consumed by this. Do not worry about changing the model yet. We're going to do that in the next module. At this point, the only thing you'd want to worry about is getting your video sources up and running.
So it looks like everything's running except for the DeepStream SDK. It looks like we have some kind of back off there.
Let's do some diagnostics. So let's head over to the Nano. And there's a few things that I think could be at play here. So we'll head on to the Nano, and we are gonna, in fact, if you're following along with the 2.6 documentation, I sort of mentioned this. Like if you do find you need to test, I give you a few example commands on how to monitor the logs and stuff like that. We are going to definitely use those right now to figure out why that's in back off.
Let's see.
So let's see. I'm sorry, I'm looking at the wrong screen, Eric. Okay.
Let's see what's running here in Docker. Camera tagging module, IoT Hub.
So yeah, we should have 5. So it looks like all of them but the DeepStream SDK. So let's do a Docker logs -f, and then you can just type the capital letter in and then tab complete it.
Yeah, it's not there.
Oh, do a Docker ps-a. Let's see what's going on here.
Oops.
Oh, that's right.
Because I haven't reloaded my session yet. So let's see. Agent Hub, IoT Edge, blob storage, tagging module.
Yes, there. Yeah, okay, we see it. Exited 54 seconds ago. All right, yeah, let's try to Docker logs that NVIDIA DeepStream SDK module real quick. It should tab complete for you. I wonder again if that's just not because, yeah, this is. So, and why Eric's having to type sudo is because his, when we added him to the user group, it just hasn't taken effect yet. Okay, so we're getting failed to create pipeline for source bin muxer. Why would it tell us that?
Could not get EGL display connection. That sounds to me like it's not connecting to X.
That is exactly the issue. Do echo $display real quick. This I noticed the same thing for me. This is the weirdest damn thing. We have this configured right now to use display number 0. But obviously the Nano is telling you it's on display 1, which is really weird because I bet you if you reboot this machine, it'll come back up as display 0.
We can do that.
Yeah, let's. Oh, and it's going to drop the screen, isn't it?
It will not for the viewers. It will for you.
Okay.
So
let's yeah, reboot this and see if that happens. And if it doesn't, I know another way to fix this. So yeah, it should reboot and come up with the proper echo or display value. I don't know why this is. It should technically be reporting display 0. But for whatever reason, I found on the very first execution, it always picks it up as display 1. Eric, do you have any hunches on why that might be?
No, I'm not sure why it would do that.
It's a mystery. And I noticed this when I was testing this, and I was like, huh, I guess that was a fluke. It set it as display 1. It means display 0.
Yeah, I guess that's something we could debug later if we wanted to.
Victim of my own complexity here. See, if we nuke X11 in the config, we don't have to worry about these types of errors. But I find that working with the X11 stuff is easier, and we discussed that on the last call. The reason why it's easier is you get a minimize, maximize, and close button. We have other options where we can service over an RTSP stream. That's a little, it's not complex, but it makes this a little more difficult than it needs to be.
All right, let's see. Actually, if I restore all of the pages, that might actually put you back on.
Oh, lovely.
Let's see.
Well, that was easy enough. I'll tell you when I can see your screen again.
Let's see. It might not give you the same URL. I'll send it to you.
I see.
All right.
Hey, guess what? It's working. Okay. You won't believe. I have visual.
Did you? All right, sweet. Okay, now let's see. Where were we? We're back in terminal.
Yeah, let's get that DeepStream container to restart, and see what it tells us now.
Let's see what our display is.
That'll work too. All right. So here's what you got to do. Here's what you got to do in that case. Head back over to your dev machine. I will add these instructions to the README. So head to the dev machine, and what we're going to do is go back to your deployment templates. Oh, sweet. You're like right there. See where I have the display and it says value equals :0?
Yes.
Set that to 1. Now, I don't know why. Sometimes it's 0, sometimes it's 1. I don't know why.
It could be based on monitors and how many outputs it has and things like that. I'm running through HDMI. Does this also have DisplayPort?
No. In fact, when I've tested these, I usually do them with 1 as well. So that's weird.
Actually, this does have a DisplayPort.
Oh. So okay. So you have 2. So you technically do have 2.
I have 2 outputs on here. There is a DisplayPort output and an HDMI output.
Weird. Mine spins up as 0. Well, it spun up as 1 the first time. I'll look into this.
Yeah, we can
anyway,
explain.
Now we know how to fix it. So I think the easy way to do it is do echo display and see what you get, and then modify the deployment template accordingly.
Yeah,
that should do it. Okay, but I'm glad we captured this issue because I have a feeling someone might encounter this. Now I'm so confident that this will work. Make sure you save that and regenerate it again. So you will right click. And by the way, that's going to become a common thing on the next few videos, this generate deployment manifest, and then apply the new deployment.
All right. Are we creating it?
Yeah, create deployment for single device.
Will this just override the one that's already out there?
Exactly.
Okay. Well, because sometimes create can be misleading. Is it actually creating a new one, or is it create or overwrite, right?
Yeah, it is. It's the latter in this case.
Okay.
I should say update. Yeah, I think would be more accurate. Now that should take hold super fast. And in fact, let's just do a watch Docker PS, and you should see that sucker come to life on the Nano. We'll do a watch.
I already see it. See it running.
Oh.
All right. So we're running. Let's go back to the Nano. Here we are.
So as much as I'd like that to just work, I'm really glad we captured that. That's.
And you said something would pop up on here?
Yeah, we should. So if you do Docker PS -A, once the deep stream workload restarts, and it's going to do some stuff like generate the. Okay, so it's up, and it's up for 47 seconds. So now let's Docker logs it, and let's follow it too. Docker logs -f. And you'll notice Eric doesn't have to type sudo anymore because he rebooted the machine, so it started a new session. Now you see how it's like halted up here, where it's just like parking? That's it generating the engine file, and we'll talk about this on the next video a bit more. So it is taking the custom vision model that exists in the custom vision AI folder. So you can find that either on GitHub or mirrored down onto your machine here. That is the model that it's using. So it's actually looking at that right now. It's generating a tensor RT based against Big Buck Bunny. And then we're going to change Big Buck Bunny to point it at this camera that I'm looking at right now.
And we're going to see whether you are indeed a human.
Sort of, because you're going to have to keep in mind that you're using a model that I trained against people and maybe only has like 100 or so images.
There we go. Here's Big Buck Bunny.
Now, so all that we have proven here is that it's connected to an RTSP stream. So you at home are probably like, what the hell? I don't want to do Big Buck Bunny. You need to see beyond that and understand we're trying to show this is an RTSP thing. And it thinks the bird is a person. So this model is interesting, but it is working and it's detecting things. That's kind of cool. It thinks that that is a cat, but that's okay. So I think this model that I ship it with is like, if you watch the video of the home security system, I'm literally shipping you that model. So it knows my home security cameras has been trained on 400 or so images. So there's some room for improvement of this model. We will tackle that in the next session when we throw the academic grade yellow V3 at this. And
it's interesting, you get to see from different angles where sometimes it detects, but then it walks the bunny walks partly across the screen, and then it no longer detects it just because the way it happens to be rotated no longer matches.
Yes, exactly. Things like that. It's it's just how it's looking at it. It's like, I don't know quite what that is.
And that's why you were talking about sampling, right, earlier, when you would look to see, oh, did I detect the car this many times in this period of time? Then it likely actually was a car.
Right. And the takeaway here too, remember what we're giving you here. We don't want to give you a project that you replicate 100% exactly as we have done. We want to give you a runway object detection against any sort of video input source. So apologies if we're not able to give you this clear example. What are you doing? We're showing you how to do whatever you want. This is what we're doing. So in the realm of object detection with edge devices. So let's you're going to notice your resources on your Nano are going to slowly become more taxed because it's running this workload. But you should have enough space, I think, to modify the config file. So let's do that next. And Eric, how close are we coming to a minute or an hour, hour and 30 minutes, 90 minutes? How close are we?
I think we started right around that time, but I mean,
oh, we're there right now. I'm sorry, I see it. We're at 1:33, so we're right on target here. So now for our finale, we need to point this at me and see if it picks me up. So
do we want to just modify that from the desktop while we let the Jetson run?
No, we want to do it on the Jetson.
Okay.
Yeah, this is.
We'll close out of this.
You can, but then you'd be, potentially leaving credentials and forking something that, So yes, I would suggest you do this on your Nano. And because we use Git, it's going to track those changes and stuff. So,
all right. Close this.
Yeah, if you wanted to resume having all your resources, we could also stop IoT Edge. We could say like sudo service stop IoT Edge. I think if you minimize it, just let me know if it's getting laggy. We can kill IoT Edge and it'll kill that deep stream workflow. But if you feel you have enough,
I just closed the Big Buck Bunny preview thing.
Oh, Edge will restart it.
Oh, really?
Yeah. Oh, yeah. That's the desired state now.
All right. Well, we'll see. It hasn't restarted it yet. So, all right. We need to go into.
So if you head to the 2.6 instructions, it should give you.
There it is. There's Edge being like, I said run.
And I will always run. Yeah. That's the cool part about that. I mean, I know you folks with that they're familiar with Kubernetes are like, that doesn't surprise me. But this is cool. I mean, and you can configure it too in ways, where you can say like, there we go. Don't spin up on failure and things like that. That can all be specified in that config.
Okay, so we have our config.yaml.
Oh, no. We want to edit the deep stream config.
Okay. So we need to go under sudo. This was data.
And yeah, you shouldn't have to sudo this one, I don't think.
Is it under? I'm trying to remember where this was located.
Then it's going to be in services. Deep stream.
There we go. Configs.
And remember, by default, we use the custom vision AI config. Yeah, Tab's your friend big time with these. I just do this on a daily basis. I'm like, yeah.
So this was the DS config custom vision AI.
That's it. Yep. And now I'm going to send you the creds, and it's okay if people see these because I'm going to nuke this camera after this anyways.
Let's see. We're going to want to do that from... Just thinking of getting the credentials here. Well, you said...
Oh, no. They're in the URL. So see that URI for RTSP? Now, for those of you wondering what kind of camera we're connecting to, we're using the company formerly known as Foscam. I believe they're Amera something. Now I forgot. I'm using the FI9821P. And the RTSP URL I'm sending to Erik now is going to contain a username and password in it. And I can't tell you how to get the RTSP URL for your camera. That depends. But once you know it, or how many cameras you want to set up, you would go ahead and set them up as such. There's some additional notes too in our instructions that talk about if you're using more than one camera, you want to increase this batch property. We talked about that in module 1 as well. But we're only going to use one camera just to keep this simple, and this should be the only thing you have to change in that instance.
All right, so I think we're good here.
Now, to force Edge to restart the container, the way I like to do it, because it also wipes the logs, because DeepStream, as you notice, is creating a lot of output. Just do a docker rm-f NVIDIA DeepStream SDK. Is tab complete not working for you on that? That's so weird.
Just depends on... it was DeepStream SDK, I think. What?
Oh, that's that RF. Yeah, docker rm-f.
Oh, you got me with that too.
Hey, you're being a little trigger happy there, man.
Recursively, delete it all.
rm-rf/star. Yeah.
All right. So we saw Big Buck Bunny die there. So I'm assuming any second now we will see your
Edge will wake up, and it should be pointed. It should be using this Wi-Fi enabled RTSP camera that's pointed at me when it comes back to life, and that's scary because you're spying on me right now in my office. But
here we
it
go.
should work. Oh, weird. It's working. And you'll see the detection is going to, I don't know if it's choppy for y'all out there, but it is detecting me as a person. So if you were to look at the Docker logs for the NVIDIA DeepStream SDK, you'll see it's a person. Now, the magic here and why you would want to tune in next time, we have showed you how to get DeepStream up and running with a series of services that we have yet to even dive into. There's so much here. Like there's so much that we have left to talk about, folks. We have shown you how to get that running as an IoT Edge module. We've shown you how to modify it. Look at that cheesing picture right there that's stuck on.
The stuck frame is always the worst possible facial expression.
Now, while this frame is stuck, when Erik gets cameras of his own and has them on his own network, realize Erik is connected on Wi-Fi over his Jetson device. My camera is connected over Wi-Fi. We are not doing the right things for capturing online.
Yeah. And we are also streaming HD video, both my stream out and your video coming in so that I can see your face while I'm talking to you and I can inject it into the stream. So we've got a lot of video content going.
It's actually a modern miracle that we're pushing this many frames, not just video frames, but like actual packets right now to get this to you. So understand that we have a custom vision AI model. So that is a service in Azure that lets us really easily train a custom model that, in some ways, I'm kind of glad this frame is stuck because it looks like it's always working. That is working. It's detecting me, and it's actually never been trained on me in this pose. I will say that it's been trained on me from afar mostly, and it's still working, which is kind of cool. So in the next video, why you would want to tune in next time? We now know how to get our own videos working, and I think when we get back here, Erik will have a camera somewhere in his home. We will show you on the next video how to make a custom vision AI model to detect anything. If you want it to be people, bananas, oranges, hot dog, not hot dog, we'll show you that. We'll also show you if you don't want to take the time to do that, because spoiler alert, training these models, you have to upload hundreds of images, and if you get to thousands, it gets even better. If you want to bypass that and you just want something that works and detects a lot of things, we'll show you how to use the academic grade YOLO v3 models that work insanely well, except for at night. They work insanely well in the daytime. There we go. You'll see it's getting some detections there. And this should essentially set you on the path to be able to develop your own custom intelligent video analytics pipeline.
I think we should get it to detect computers so that we can put a camera in Brian's office and have it alert people when he's acquired too many again.
That's a great idea. I didn't know that Brian had that kind of addiction.
Brian has that kind of addiction.
Yeah, that's a cool one, though.
That's
is. But yeah, so we could automate the intervention. Like you have too many now.
See, Aaron's laughing. He knows.
Would you wager that Brian has more computers than I have video game consoles?
Probably. I mean, I don't know when the last time he got rid of video game consoles or computers was.
Like, is a game console a computer is what I'm getting at, and I'm wondering, like, I want to.
It depends on how recently he purged. But,
so I don't know why I'm getting the freeze here. Oh, there we're getting some additional detections now. That was so weird. Yeah, froze for a moment there. But yeah, we're getting those detections again, and life is good. Look at that. Person. And we'll also show you how you filter those results.
Aaron says, I assume he has more computers than the GDP of a small country.
That sounds fun. In fact, if we do detect that, then we could train it to go onto Goodwill auctions and buy computers for him that come up for auction to further facilitate his addiction. So I hope y'all are excited here. Like, this is the part where we're going to start making it our own. At this point, like, update it to use your camera, right? And come back and see us. Like seriously, follow us and come back next week. And then we will show you the custom models on our next episode.
Yeah, I guess let's kind of forecast a little bit what we're doing the next couple of episodes. So we're going to be recording how many next week? 2?
We're going to shoot for 2. We're ready to shoot the next one. We just need to make the content for module 4. But yeah, module 3 is next on the dock.
So we should be streaming twice next week. And in those episodes, we're going to do custom model stuff, right?
Correct. We'll do custom models. It'll be a flash course in ML and AI, object detection algorithms in general. Honestly, don't miss it. I mean, like, this is going to be some cool content.
And
really, really cool.
And then the episode after that is...
Then we talk about Azure services. So, and the other thing we'll talk about too on the next one is tweaking these models. So we can actually, so you might notice, like, if you're paying attention to the frames when it is gathering them, sometimes it's detecting and sometimes it's not. We'll show you how to tweak that for higher accuracy and stuff like that. So.
Yeah. So next week we'll be shooting the one where we're going to do custom object detection models and stretch goal of also recording the one where we talk about recording telemetry.
Yes.
And then we have our 5th one, which will be the following week. And then we have potentially a special episode planned.
Yeah, there is some talk right now with friends from NVIDIA that might join us on a secret 6th module. That would probably be some sort of retrospective and also going forward for these types of solutions. So hopefully that's something you'll want to tune into. But I'm loving this so far. I mean, Eric, like, we're doing this.
Yeah,
you're going to have a whole security system.
Yeah, this is going to be fun. And then I love the idea of expanding upon this. Like, could you get it to recognize license plates and who comes and goes out of your neighborhood and whether this person is new and things like that? Is your neighbor coming in at odd hours of the night and they don't usually? Like, I don't know. Right.
Yes, the sky is the limit here. And we will, we'll talk about like what the feasibility is in the models section, because there's remember, we're using object detection models, so they're very good at detecting objects. So think about an object you would want to detect and what that could be useful for, and we'll show you how to make that. So this will be fun.
Yeah, this is a lot of fun, and I'm really looking forward to some of the future episodes.
Excellent. So I think that's a wrap for today. I don't want to leave you all, but if we show our hand now, we won't have content for next week. So we'll cut it about here, and I'm happy with things. Any closing comments, Eric?
No, this is going to be a blast, and I'm really looking forward to the next episode, because even doing custom model training is new to me. So that's going to be a lot of fun. And
excellent.
So
all right, folks.
All right, awesome. Thanks, Paul. Thanks everybody for joining. I'll send out links and stuff next week when we go to do our recordings. If you want to participate live, it's always more fun. If not, these will be archived to YouTube. We'll put the link to this particular repo and any other things we discussed. I know there were a couple of things we talked about linking. Which particular cameras, or at the very least, what features you would need to look for if you're going to buy your own cameras to follow along. I'll put that in the notes for both Twitch and YouTube. Twitch is only going to keep this video for like 14 days, but YouTube, it'll be there forever. And I think if you have the link to this repo, I think Paul is updating this repo with the videos as we shoot them too. So if you want to follow along in video format, you can watch the recordings in place as we record them. So I guess with that, thanks everybody for joining us, and we hope to see you all on next week's episode where we do some custom model work.
Awesome. See y'all next time.
Bye, everybody.